Hello. Yeah. I'm audible, everyone. Okay. So, in the previous class, what I have taught you, I was teaching you alternating current. In that, we discussed the magnitude of RMS value of the current. Yes or no? So, we discussed RMS value. RMS value we have seen, and that came out to be if I equals to I naught sine of omega t. RMS value is how much? RMS value is I naught by root 2. Yes or no? If you have been given if I equals to a sine of omega t plus b cos of omega t, let's say like this, then its RMS value will be how much? It will be under root of a square plus b square by 2. If I equals to I1 plus I2 sine of omega t plus phi, any function I'm saying, then its RMS value will be how much? Under root of I1 square plus I2 square by 2. Okay, remember this result. Okay, Okay, finish everybody. RMS value and peak value. Okay, now next important point, pay attention. All the given readings when you purchase anything from the market, okay, that can be anything, let's say bulb, so their rated power, rated voltage are given. Generally, these two are given, okay, or the charger or anything that works on AC supply. Their rated power, rated voltage are given, or rated current are given. So all these readings are given in RMS values, okay. Or whenever we are going to take any measurement using ammeter, using voltmeter or galvanometer or wattmeter, wattmeter which is used for measuring power. So all these readings will be taken in which in form, RMS. Okay, all the readings will be given in RMS form. Note it down. All the rated readings, rated voltage and current are given in RMS reading. Reading of ammeter, voltmeter or galvanometer are given in RMS value. Reading of ammeter, voltmeter or galvanometer are given in RMS value. Okay. Now we will see phases. Okay. Before phasor, we will try to understand some basic element circuits like uh, purely resistive circuit. Resistive circuit. In purely resistive circuit, you will have a resistor which is connected across alternating source. This alternating source is what? V equals to V naught sine of omega t. Resistance is what? R. Apply KVL in the circuit. Applying KVL, what we will get? I will write V naught sine omega t minus of IR equals to how much? 0. I get here I equals to V naught by R sine of omega t. This can be also written as I equals to I naught sine of omega t. I naught is your V naught by R. That we also say it as peak current. What is this value? Peak current or maximum current. Okay. So I is I naught sine omega t and V is how much? V naught sine omega t. You can see that these terms are same in both of them. Yes or no? So here current and voltage both are in same phase. What is the meaning of same phase? When current is maximum, voltage is also maximum. When current is minimum, voltage is also minimum. When current is zero, voltage is also zero. Identical behavior. Is that clear? Understood? So we said they are in same phase. Here current and voltage are in same phase. Okay. If I plot the profile of I or V versus T, V or I versus T. So let's say this is V. So current profile will be exactly identical, like this way. This is your current profile. Okay. So they are attending their maxima together, they are attending their minima together, they crosses their zero value together. Okay, they changes directions together exactly in a same manner, means one is copying the other. Okay, is that clear? So this is a case of pure resistive circuit where we have only resistor and AC source. Okay, so in purely resistive circuit, what we see, current and voltage are in same phase. Next one is your what? Purely capacitive circuit. Purely capacitive circuit. In purely capacitive circuit, what we have? We have capacitor which is connected across an alternating source, that is V equals to V naught sine of omega t. Capacitance is what? C. Let's write the KVL equation. Applying KVL, what you will say? V naught sine omega t minus Q by C equals to how much? 0. Yes or no? So we will write Q equals to C V naught sine of omega t. And I require current. So dq by dt will be how much? Dq by dt will be C omega V naught cos of omega t. So dq by dt, that is I will be written as V naught by omega C cos of omega by 1 by omega C. Okay, cos of omega t. This will be also written as V naught by Xc. Xc is the resistance offered by the capacitor. Cos of omega t can be written as sine of omega t plus pi by 2. What is Xc here? Xc we say capacitive reactance. What is this one? Capacitive reactance, whose value is how much? 1 upon omega c. And if I plot the current versus voltage profile, then you can see, let's say this is the V profile. So what is current profile here? Current leads the voltage by how much angle? 90 degree. So the profile is like this. Did you get my point? This is your V equals to V naught sine omega t, and this is your I equals to I naught cos of omega t or sine of omega t plus pi by 2. So here current leads the voltage by how much angle? What is the phase difference between them? Which one is more? Omega t plus pi by 2. So current leads the voltage by a phase angle of 90 degree. Okay, so you can write it a note here that in purely capacitive circuit, current leads the voltage by angle how much? 90 degree. Is that clear? Understood? Note it down. So this is very basic. In purely resistive circuit, current and voltage are in same phase. Okay. Whereas in purely capacitive circuit, currents leads the voltage by phase angle of how much? 90 degree. Okay. Now third one is your what? Purely inductive circuit. In purely inductive circuit, this is inductor that we have that is connected across an alternating source. V equals to V naught sine of omega t, and this is L. So if you apply KVL, what you will write? Tell me. V naught, I'm assuming current is going in this direction. V naught sine omega t minus L di by dt equals to how much? 0. Yes or no? So what I'm going to get here, I will be getting di equals to V naught by L sine omega t dt, and we will integrate it. Yes or no? Is that clear? Yes. Now t equals to 0. What is the current flowing in the circuit? T equals to 0. Current flowing in the circuit will be how much? So t equals to 0. There is no EMF. So current should be how much? 0. Okay. And t equals to t. Current is I. If you integrate it, what you are going to get? You will be getting I equals to V naught by L sine omega t. Integration will become minus of cos omega t. Yes or no? Minus of cos of omega t by omega. Yes, 0 to t. So I we are getting here as how much? V naught by omega L, and this is 1 minus cos of omega t. So I we got here V naught by omega L minus V naught by omega L cos of omega t. So here you can see that we have this component. This component is your DC component because it is constant, and this is your AC component. So which component we are studying right now? AC component. So IAC is how much here? V naught by omega L cos of omega t. This can be written here as V naught by omega L cos omega t, can be written as sine of omega t minus pi by 2. Can be write it like this way. Sine pi by minus of pi by 2 minus omega t will become minus cos omega t. Yes or no? Simple rearrangement. Now here you will see IAC is how much? That is V naught by omega L is what? XL sine of omega t minus pi by 2. What is XL here? Inductive reactance. What is XL here? Inductive reactance. Yes or no? XL is equals to how much? That is omega times L. And here what we understand, that current leads or lag. Current lags the voltage by how much amount? By 90 degree. And if you see the current versus time profile, I versus T or V versus T, the profile will be V or I. So V is like this way and current is like this. Okay. So this is V equals to V naught sine omega t, and this is I equals to how much? I naught sine omega t minus pi by 2. Okay. So whatever we have discussed till now, these are most basic things. Okay, these are most basic things. In purely resistive circuit, current is in phase with the voltage. In purely capacitive circuit, current leads the voltage by phase angle of 90 degree. And in capacitive circuit, current lags the voltage by phase angle. No, in inductive circuit, current lags the voltage by phase angle of 90 degree. And in capacitive circuit, current leads the voltage. Or I can say voltage lags from the current by phase angle of 90 degree. Is that clear? Other important point we need to remember that how the resistance offered by the inductor and capacitor depends on the value of omega. You can see XL is omega times L. So when omega is more, when frequency is more, resistance offered by inductor will be more. When XC omega is more, XC is less. Omega is not constant. Omega is the frequency of the alternating source. Yes, sir. So if omega is not constant, how XL will be constant? Omega can be changed. No, manually we can change the value of omega. Omega is what? How fast or slow the turbine is rotating, which is creating this AC, or that rectangular coil is rotating. If the coil is rotating with very fast rate, then omega will be more. If it is rotating with a slow rate, omega will be less. Yes or no? When omega is 0, that means DC current. When omega is 0, that means DC current. Yes or no? And in case of a DC, inductor offers zero resistance. Whereas when omega is more, when omega is 0, DC current. Omega 0 means DC current. DC current means constant current where direction is not changing. Capacitor blocks DC. Yes or no? Capacitor blocks DC current, whereas inductors allow DC current. Because when DC is passing through capacitor, capacitor gets charged, and after charging, it will not allow the current to pass through it. Whereas through inductor, when DC current will pass, magnetic field will not change because this is a constant current. Constant current means magnetic field is constant. Magnetic field constant means flux is constant. Flux constant means flux change is zero. So no EMF. No EMF means no opposition. Inductor supports DC current. Capacitor blocks DC current. That concept we will use in the filter circuit in semiconductor. Now, when omega is high, means frequency is more, means repetition is high. Yes or no? Many times it changes direction. When omega is high, that means resistance offered by inductor is more, because more the current is changing its direction, change will be more. Flux change will be more, means EMF induced across the inductor will be more. So it is going to oppose more. Whereas capacitor do not change the do not provide resistance to high value of AC current. Why? Because omega will be more. So this term will become, let's say omega tends to infinite, this term will become 0, XC will become 0. So capacitor, when omega is higher, capacitor offers zero resistance. When omega is lower, inductor offers zero resistance. Is that clear? Yes or no? We will see all these things very soon. You will understand everything. Don't worry about it. This is clear, everybody? Now, whatever we have studied, we will try to understand all these things with the help of a simple phasors. Okay. So phasors is what? Phasors is a notation to represent it in a vector form. All sinusoidal functions can be represented in a vector form, and that representation is known as phasors. Okay. So like you have been given v equals to v naught sine omega t. So in phasor form, I will represent it like this way. Okay, it will be v naught will be represented like this way. This is v naught v phasor. V phasor is v naught angle 0 degree. This is the reference that is taken here. Try to understand everybody. Okay. If I say v1 equals to v naught, or let's say v naught sine of omega t plus phi, that will be represented here like this way. This is v1 phasor. This angle will be how much? Phi. Okay. And its magnitude, this is how much? V naught angle 0. V naught is telling its peak value. An angle tells here that how much it is ahead of this one. How much ahead? Phi angle. Yes or no? If V2 I represent it like this way, V naught sine of omega t minus phi, that means this is your V2 phasors. Okay, this is V naught angle minus phi. Is that clear? Did you get my point? Suppose I say that I equals to I naught sine of omega t minus 60 degree. That means what? I will represent, this is the reference line omega t. How much below? 60 degree. This is I equals to I naught, I phasor, no arrow, simply bar. I naught angle minus 60. Is that clear? Understood? Understood? Now addition of phasor always triangle law of vector additions. Okay, addition or subtraction of phasors always triangle law of vector addition. So we are just going to treat them like a vector. You got my point? Addition of phasor or subtraction of phasor, addition or subtraction of phasors obeys triangle rule. Which rule? Triangle law of vector addition. So suppose you have been given, pay attention, suppose you have been given y phasors equals to y1 phasor angle phi plus y2 phasor angle phi 2, let's say, or theta 1 theta 2. So we have to add these two. How we will add them? I will say that, sir, this is our y1 phasor, this is our y2 phasors. Okay, this angle is how much? Theta 1. This angle is how much? Theta 2. I can use parallelogram law of vector addition or triangle law like this way, and then this will be the resultant, that is y phasor, which is making some angle here with how much? Delta. And this angle is how much? Phi theta 2 minus theta 1. So y phasor will be written as here y angle delta. So we have to calculate y and we have to calculate delta. What is y? Y is the magnitude of the sum of two vectors. What will be the magnitude of sum of two vectors? Under root of y1 square plus y2 square plus 2y1 y2 cos of theta 2 minus theta 1. Yes or no? So I will write y as how much? Under root of y1 square plus y2 square plus 2y1 y2 cos of theta 2 minus theta 1. And tan delta will be how much here? I will add their y components together. I will add their x component together and then divide. We'll take the ratio. So y component will be how much? Y1 sine theta 1 plus y2 sine theta 2 divided by y1 cos theta 1 plus y2 cos theta 2. Understood? So we can easily get the value of delta. This all we have discussed in vectors. Yes or no? Very easy thing. So delta will be tan inverse of whatever is there. We will simply write it. So what is y? Y will be y resultant that we have got here. Let's say y r. I am saying it as a, okay. So y r sine of omega t plus delta. Understood? Is that clear? What is y1 here? Y1 is y1 is y1 sine of omega t minus theta 1, and y2 is how much? That is y2 sine of omega plus theta 1 plus theta. Is that clear? Yes or no? Any problem in understanding it? Simple and straightforward. We have to treat them like a vector. In vector, what we require? The magnitude and the angles. Yes or no? So same way we can represent it. Remember the result, how we calculate the resultant and how we calculate the delta. Okay, I will give you one question based on this to practice right now. First you note it down. Mhm. V naught sin omega t represents alternating source, alternating voltage, which will drive the circuit. This we also said as a periodic EMI, no? Periodic EMF also. Huh? B is the V naught is the maximum voltage and V is your voltage. Where V1 is there? These are just different forms. We have three voltage. I have represented it like that way. It is not necessary that every time I will get voltage as V naught only. It may be V1. For other source, it may be V2. So how I will represent it in phasor form that has been shown there. Okay, different forms. Magnitude I have changed. Then I have changed the what is where, but where is V1? Yeah, V1, V2, V3. These are the different phases. Voltage V naught sine omega t minus phi is there. There is some other source voltage. Finished, everyone? Why just a phasor? It can be current, it can be voltage, it can be anything, a function of sine and cos. What is why? You were present in the class while I was explaining it. Why you're asking these questions? Why just a simple I have to consider any random phasor of magnitude y and phase angle theta 1. Finished? Now first you try to understand these phasors. This is a addition part, addition and subtraction. The entire chapter is basically phasors only. Okay, you have to understand the phasor applications, then the chapters will be very easy. Suppose you have been given I1 equals to 3 I naught sine of omega t minus 37, and I2 is given as 4 sine of omega t plus 53. They're asking you find I1 plus I2. Okay, we have to add these two. So first I will represent in a vector form. I1 is how much? 3. Angle is how much? Minus 37. So this is length is 3 and this angle is how much? Minus 37. This length is 4 and angle is 53. Yes, this is 53. This length is how much? 4. You can see the two vectors I1 phasor and I2 phasors are 90 degree to each other. Yes or no? They are 90 degree to each other. And if I just try to make it little simple, then let's make it 4. It will be easier to understand. So resultant will be how much when two vectors are at 90 degree? What will be the resultant? 4 root 2. Yes or no? I will be under root of 4 square plus 4 square plus 2 into 4 into 4 into cos of 53 minus of minus 37. How much we will get here? 4 root 2. If two vectors are of equal magnitude, resultant passes through the middle of them. Yes or no? This is I. I is how much here? 4 root 2. And what is the angle here? So this angle will be 45 and this angle will be how much? 45. So this angle is how much? 8 degree from the reference line. Yes. So I will write I equals to how much? 4 root 2 sine of omega t plus 8 degree. Is that clear? Yes or no? Understood? Note it down. So I am giving one other question, like you have been given y1 equals to 4 sine of omega t, y2 equals to 4 sine of omega t plus 60 degree, and y3 equals to 4 sine of omega t plus 120 degree. And I'm asking you find y1 plus y2 plus y3. Huh? Y1 will be 0. Theta is not there, means theta is how much? 0. Try the second one. Finished everyone? So represent in vector form. How will you represent? This is 4. This angle is 4. This angle is how much? 60. This angle is 4. This angle is how much? 120. Yes or no? So I will solve it like this. So 4 will be already here. Okay. And you can see that, just forget about this 4. If you see this 4 and this 4, they are equal vectors of magnitude wise. They are equal. And the angle between them is how much? 120. Resultant will pass through them from the angle bisector. Yes or no? How much angle? 60. And if you calculate the magnitude of these two, will come out to be how much? 4 itself. So 4 and 4, how much it will be? 8. 8 angle how much? 60. So answer will be how much? 8 angle 60 degree. That is y equals to y1 plus y2 plus y3 will be how much? 8 sine of omega t plus 60. Understood? Yes or no? Not understood? 1 minute. Yes or no? Or you can use that old method, break this 4 into component. So this will be how much? 4 cos 60 in this direction. Yes or no? And this will be how much? 4 sine 60. If you break it into component form, the other one will be how much in this side? 4 cos 60 here and 4 cos 60 here. Yes or no? 4 sine 60. Yes. You can see that 4 cos 60, 4 cos 60 will cancel. And here we have 4 and here we have how much? 8 sine 60, that is 8 root 3. 4 root 3. Yes or no? 4 root 3 and 4 are perpendicular. Resultant will be how much? 4 common under root of 3 plus 1. How much we will get here? 8. They are perpendicular, so resultant will be a square plus b square under root. So 4 will be common, under root of 3 square will be 3 plus 1. 4. Root 4 is how much? 2. That is it. And how much angle it is making? Delta. Tan delta will be how much? Tell me. 4 root 3 by 4. That is root 3. So delta will be how much? 60 degree. Yes. Understood how to add the two phasors? Any problem in adding the two phasors? Finding the phase? Clear? Understood? Okay. So this is regarding the addition or subtractions of two phasors. Now the next one that we have, that is multiplication and division of phasor. That is also going to be used a lot here. Multiplication and division of phasors. You have studied complex number, everybody? Complex number you have studied, na? Then it is very easy. This is clear? Fine? Okay then. Complex number are represented like this way, Z. Z is what? Notation for a complex number. Z phasor is what? That is Z angle theta. Yes or no? Yes? Now suppose you have been given Z1 phasor as Z1 angle Z1 phasor, let's say that is A angle theta 1, and Z2 phasor as A B angle theta 2. So if I write Z1 phasor into Z2 phasor, how you multiply complex number? Sir, we multiply their magnitudes and then we add their arguments. Yes or no? You know this or not? चलो कम से कम इतना तो आता है. Z2 phasor by Z1 phasor, how you divide them? Sir, we divide their magnitudes and subtracts their arguments. Is that clear? Yes or no? Same thing we are going to do here. You have been given y1 phasors equals to 5 angle 30 degree, y2 phasor that is 10 angle 60 degree, or let's say 10 angle 70 degree. What is y2 phasor by y1 phasor? What you will say? Say 10 by 5 and 70 minus 30. How much it is? 2 angle 40 degree. So this is y phasor. Y phasor will be written as how much? 2 angle 40. So y will be written as 2 sine of omega t plus how much? 40. Yes or no? Tell me, this is clear now? Clear? Understood? Now whatever you have learned about this phasor, now we are going to use it in circuits. Okay? Make sure you are understanding everything. Any point, if you have a doubt, feel free to ask. Doubt? Doubt? Why you are making your face so bad? Huh? Don't make any kind of a bad faces. I don't like bad faces. I like a smiling faces. I can read your faces. You know this? Every teacher is expert in reading the faces. As looking at face, they will understand what is going through your mind related to the subject. No? Other things we don't know. Otherwise, we could have the Babas of India. And this is the best way to convince anybody. You just read their face and tell what is going through their minds. This is clear, everybody? Now we are going to consider three hypothetical phases which will be important for our discussion. Three hypothetical phases which will is our calculations. Okay, it will make our calculation very easy. We will be very comfort in doing the calculations. In reality, it is not existing in that way. But to make our calculation easier, we are going to take the help of these features. Like in magnetism, we assume that the magnetic monopoles exist to understand the magnetic field of the magnet in its surrounding. Yes or no? Same way here also we are going to discuss three hypothetical phases which will make the chapter easy for you. Yes. So the three hypothetical phases are, first of all, your resistance phasor, that is R angle 0 degree. That does not mean that you will write R equals to R naught sine of omega t. If somebody is writing like this way, I will break your head. You will not write like this way. Resistance is a constant function. Is that clear? Just to understand it, we will be taking help of these phasors. Okay? Understood? Yeah. समझ में आया? Next phasor is your XL phasor, that is denoted here. That is omega L angle how much? 90 degree. And the next one is your which phasor? XC phasor. XC phasor will be like this way, yes or no? And XC phasor will be how much? 1 upon omega C. Angle how much? Minus. Is that clear? Yes? Understood? We have to remember this thing. Now, look here. This is purely resistive circuit that we discussed. Yes or no? In that, what we have seen? Current and voltage are in same phase. Yes? V equals to V naught sine omega t. If I have to write I phasor will be written as V phasor by R phasor. Yes? What is V phasor? Sir, V naught angle 0 degree. What is R phasor? We have assumed how much? R angle 0 degree. What value we get here? V naught by R angle 0 degree. That means this is our current and voltage phasor will be also exactly in the same. Is that clear? Current and voltage are in same phase that we have studied. Yes or no? For example, if I say that this is our resistance and the alternating source is like this way, V equals to V naught sine of omega t plus phi. What will be I phasor if I want to write? Tell me. I phasor will be, tell me, V phasor by R phasor. What is V phasor? V phasor is how much? V0 sine omega t. V0 phi and R angle 0. What we get I phasor? V naught by R angle phi. Phi is a phase. Have you studied wave? Phi is an angle. Okay. Because I cannot go to that much basic now. What is anything written in the box? Angle. Understood? Is it clear? Phi is also angle. क्या तुम भाई ऐसे कैसे काम चलेगा? Is that clear? If I represent V as a phasor form, how much angle it is ahead? Phi, sir. What is I phasor? Angle phi. That means it is in the same sense. Yes or no? Is that clear? Understood? Yes. V phasor and I phasor are always in same phase. Current and voltage are in same phase across resistor. Let's talk about capacitor. In capacitor, this is Xc. B is how much? V naught sine of omega t. Yes or no? Okay, here remember, if I represent the voltage across R, voltage across R will be how much? V across R phasor will be I phasor into R phasor. Yes or no? I phasor is how much? V naught by R angle phi. R phasor is how much? R angle 0. How much we get here? V naught angle phi. Yes or no? So I phasor is like this way here and V phasor is also in the same sense. V across R. Are you understanding it? This is how we represent on the coordinate axis, na? Yes or no? नहीं आ रहा समझ में? सर फोड़ लो गचेड़ो सब क्या तुम लोग हो क्या दिक्कत है what you have to understand in V naught angle phi? V naught is the magnitude. What you want to understand there? What question you are asking, man? V naught is the magnitude. What you have to understand there? Y equals to 4 sine theta. Do you know this function? What is 4? So what is V naught here? V naught angle V. What is V naught here? And what is this? Sine. Sine function means what? Periodic function. What is the definition of AC current? A current which changes periodically with time. So there should be a function, na? Why you think like this way that I will say V equals to 12 volt? If this notation is given, that means what? This is the notation for AC. That is for sine or cos. It's not like this way. This is for DC. This is for AC. You are asking the same question every time. Sir, what is this V naught sine of omega t? Arey yaar, ye yesterday we have discussed AC current. We calculated RMS value. We calculated average value. Still you are in that there only. There you should have asked na. So what is this sine? What is this cos? हाँ तब क्या दिक्कत है? अब मैं समझा देता हूँ तो बोलता है अंडरस्टूड. नाउ टेल मी वेयर इज द डाउट. What doubt you have? Huh. What you have studied here? What is this? That's not the way to solve it, na. We cannot solve it like this way. Sin omega t plus phi by cos omega t plus phi, what value you will get? It's not mathematics we are dealing with here. Everything cannot be done using the same basic rules of the mathematics. Huh? In math, we know na 2 plus 2 is how much? 4. In physics, what is 2 plus 2? Sir, it is anything from 0 to 4. Because here vector rules are applicable. Here phasor rules are applicable. That's why we are studying phasors. We are not stupid. That everywhere we will use the same concept. Huh? Why we cannot write? We cannot write because by that way we will not get what we want. No need to be sorry. Why you are sorry? See, I'm not shouting. I'm just making joke of it. I'm enjoying it because everybody is like laughing. So that's a good thing. At least never think that I am angry. This is when I start to laugh. Understood? Sir is enjoying this scene. Don't get like I'm sorry. So why you will be sorry? You are asking question. That's your right to ask. Huh? When you will ask a stupid question, my answer will be also is full of stupidity. Yes or no? Understood now? Understood? Sure? Because few minutes before I asked the same thing. Understood? Yes, sir. And then after again you asked it. So next time when you will ask, more stupidity I will say. क्या भाई ऐसे कैसे होगा? Okay, everybody, this is clear. Why they are in same phase? From this data, we are seeing that they are in same phase. Here we have used the concept of multiplication. Can you see here? For finding current, I have used the concept of divisions. Yes or no? चलो इसमें अप्लाई करते हैं. V naught sin omega t xc. I have to calculate current. We will calculate using phasors, not sir I equals to V by R. Okay? Proper method is there that we have to follow. I phasor, what is right? V phasor by xc phasor. Tell me what is V phasor? V naught. One more important thing. Do not try to answer your board question or a school exam question using this method. Otherwise, teacher will put a big zero if they don't know this. And if they have taught you exactly in the same manner, then they will be giving you full marks. Okay? So make sure how they have taught you in the school. Okay? Okay. हाँ तुम भी बोलो क्या दिक्कत है बोर्ड्स नहीं बोर्ड्स में कर सकते, you can do in the board because in NCERT they have solved it like this way only. Okay, but I don't know about the schools because here schools teachers are like they're extraordinary. They too don't know what they are teaching. Yeah, I know. Why they will teach you all this? That's why. That's but here it is different. Try to learn what I'm teaching you. I'm not your board teacher. You have paid me lakhs of rupees. You know, isn't it? Hmm. क्या पैसा जोड़ रहा है? हाँ दिए आपको, हमको नहीं दिए हो, सिस्टम को दिए हो, सिस्टम हमको पे करता है। वाह, वो तो लग्जरी है, गिविंग दिस मच अमाउंट ऑफ मनी कमिंग हियर फॉर स्लीप। Yeah, that's a best thing. Suppose somebody in your house is not getting proper sleep. Okay, you send it in Ellen. Okay, he will understand nothing, and then what will happen? The classroom is the best place to take, have sleep, because there in that you will feel relaxed when you are sleeping. Because when you will be awake, a lot of information will be going. Like suppose a day you want to study 100%, understand 100%, full focus. After the class, when you will go out, now your head will feel like a big, like 10 ton, 5 ton things are there over your head. Yes, when you are not studious, because that is heavy for no any information which is going in your mind. If it is not absorbed by mind, then what will happen? It will revolve there only. What is the meaning of hypothetical? Uh, Hypothetical means just we are using it to solve our problems. You know, after doing all the calculations, the author or the scientist who has made this theory, okay, they thought that if the students has to learn this thing, and if they go by the basics, they will not able to solve the problems. They will have always headache about it. So they gave us another approach by conclusion. Okay, after doing, because those who have studied it, they know what is happening here. Okay, so to make it easy, they said it, okay, you can go like this way. By this way, it is easier to solve the problem. Understood? So you don't require to understand what is hypothetical failure. Hypothetical failure is this. Okay, did you get my point? You are afraid of God. Who is your God? Who is your God? Hindu God. Okay. In Hindu, we have Brahma, Vishnu, and Mahesh. Yes or no? Shiv, Shiva, Narayana, and Brahma. Yes. Why they are? Why you are afraid of him then? Who they are? Have you seen him? No. But you follow him. Why? Why? Because if you will not follow, something bad will happen with you. Yes or no? If something bad has to happen, if you are following him, automatically good thing will start to happen. Yes. It's maintaining balance in your life. Yes or no? Same thing here. These three hypothetical figures will maintain balance. Okay, understood? It will maintain balance. Oh, it's good day. I was in the whole day. I was bored. Now I'm very much happy. Good entertainment. That's why I call for you extra sessions. I get these doses of entertainment in the class. Okay, let's write V naught angle 0. X is how much? Tell me. XC, what angle we have here? XC phasor angle is how much? X is 0, stupid. Minus pi by 2. Yes, no? Now what will happen? This will go up B naught by XC. Yes? And this will go up, will become how much? Pi by 2. And XC is how much? V naught omega C angle pi by 2. Yes? XC is 1 by omega C. So I phasor will be how much? I will be how much? I naught. I naught is how much? V naught omega C sine of omega t plus pi by 2. That we have discussed. Yes or no? Yes. First, we have seen through the integrations and differentiations. Now we are trying to study the same thing with the help of phasor and trying to learn a new method to understand these concepts. Is that clear? Current leads the voltage by how much angle? Current leads the voltage by how much angle? 90. This is your V phasor. Look, this is your V phasor. How will be your current phasor then? Current phasor will be like this. Understood? What phase angle? 90. Is that clear? Similarly, we can do for which one? Purely inductive circuit. Purely inductive circuit. In purely inductive circuit, what we have? Inductor. Now try to answer this question by your own. Okay. So tell me everybody, what are we write? I phasor equals to how much? V phasor. I be write V by R. Yes or no? So R we will write V. I phasor I will write. Instead of that, what I will write? I phasor. Instead of I, what I will write? I phasor. Why we are doing this? Because in AC phase is very important. Yes or no? In AC, what is important? Phase. That's why instead I writing V by R. Okay, what we will do? V phasor by R phasor or XC phasor or Z phasor, that you will see in the coming part of the discussion. Tell me, I phasor, what we write? B phasor by XL. What is XL phasor? Tell me. Omega L 90. Yes or no? This will go up. What it will become? Minus. Yes or no? So I is how much here? Tell me. V by omega L sine of omega t minus pi by 2. Yes, this is clear. Current is lagging or current is leading here? Current is lagging. This is V phasor and this is I phasor. Current lags here by how much angle? 90. Understood? So it's quite easy to remember. If we just know these three hypothetical phasors, we can easily say current will lag or lead. Yes or no? Okay? Chalo, note karo. Note it fast, then we will see the general circuit where we will have resistance, capacitance, and inductance together. समझ में आया तुमको? Understood? Good. हाँ, क्या चीज? Everyone, this is clear now. Now we are going to discuss the most important part of this AC circuit, when all the things will be together: capacitor, inductor, and resistor. In that case, we have to see how current varies with time, how to calculate phase, how to calculate readings, okay, how to calculate power, and how to calculate, like you had calculated na equivalent resistance. Here also we have to calculate equivalent resistance for series, for parallel. A lot of things are there to be done. Okay, so make sure you do not miss any of the part. Try to focus, everyone. Okay, so we have a general circuit which involves all three. This is capacitor, in resistor, and inductor. If I ask you, if anything has to be same through all of them, what will be same? Huh? What will be same through all of them? Current will be same because all are in series. I. Yes. I will be same in all of them. Yes or no? Okay. So first of all, we will try to calculate the net impedance of the circuit. Net impedance of the circuit. So what is impedance? What is impedance? It is the total resistance offered by the resistor, capacitor and inductor of the circuit. Okay, in the flow of current. What is impedance? It is the total resistance offered. It is the total, it is the measure of opposition or you can say it is the total resistance offered by the circuit, and it is noted Z. Z is stands for here impedance. Okay, and how we calculate Z here? So Z will be calculated like this way. This is for series. This is what we are doing for series circuit. Now look here. This is for XL. Yes or no? Yes, everybody will pay attention. This is your XC and this is your R. These are three phasors shown in the vector form. We have to find their resultant. How we will calculate the resultant? Sir, which are along the axis? Same axis will be subtracted or added. So this will become XL minus XC, assuming XL is greater than X. And this will become R. Resultant of these two will be what? Resultant of these two will be Z. This angle will be phi. So what is Z here? Tell me. Root under R square plus XL minus XC of whole square. And how to calculate phi? Tan phi will be how much? XL minus XC by R. Yes or no? We will have a term that we say cos phi, that is power factor. In the coming part you will understand power factor. Okay, this is Z. So what is Z phasor? Z angle phi. Z phasor is how much? Z naught angle phi. That's the value of Z naught, or you can simply write no problem. Is that clear? That's a net impedance of the circuit. That is your net impedance of the circuit. So if I ask you what is current in the circuit I, so I phasor will be how much? Tell me. V phasor by Z phasor. What is V phasor? Sir, V not angle 0. What is Z phasor? Z angle how much? Phi. Yes or no? What we get? I phasor equals to V naught by Z minus phi. Yes. फिर हंस रहा है तुम, क्या दिक्कत है? सर नहीं समझ में आ रहा? अंडरस्टैंडिंग इट? गुड. समझ में आ रहा है इसलिए हंस रहे हो? नाइस. Now, so I will write I equals to how much? V naught by Z. Z is how much? Tell me. R square plus XL minus XC square. And this will be written sine of omega t minus phi. Yes? Is that clear? This triangle that you see here, this triangle is known as which triangle? Impedance triangle. This triangle we say it as a impedance triangle, because with the help of this triangle we are able to find the impedance of the circuit. Is that clear? Okay. Now if I show you the voltage and the current across each element of the circuit, here you will understand the role of this phasors. Voltage is in this, like this direction, yes. Current leads or current lags here? Current is leading or current is lagging? What is this? Minus phi. So current lags by how much angle? Phi angle. Current through all the circuits will be same. Why? Because all the elements of the circuit will be same. Why? Because they are in series. If I write V across capacitor, what you will say? V across capacitor, I across capacitor into XC. Yes or no? I across capacitor is same as I angle minus phi. Yes. I angle minus phi. Yes or no? And what is XC? 1 upon omega C angle minus pi by 2. Yes or no? So what we get here? I by omega C. Yes. So yeah, I by omega C angle minus pi by 2 minus phi. Yes. So how much angle below? This is already minus phi, and in from here how much? 90 degree. This is V across C. Is that clear? I and V. Voltage across capacitor, you can see this is lagging by how much angle? 90 degree. Step by step try to understand. Clear? Now if I write V across R, what you will say V across R? Tell me. I across R phasor into R phasor. Yes or no? I across R phasor is I angle minus phi times R angle 0. What you will get here? I R angle minus phi. Means voltage and current are in the same phase over here. Yes or no? So here this is your current phasor and this is your voltage phasor. Same phase. Whereas if I write voltage across inductor, what you will say? V across inductor will be I across inductor phasor cross XL phasor. Everything is same. Only instead of simple IR, what I am writing I phasor R phasor. Yes or no? I phasor is how much? I angle minus phi. And what is XL phasor? Omega L angle pi by 2. We get here I omega L angle pi by 2 minus phi. Means like this. V across which one? Inductor. Is that clear? Understood? If I draw voltage phasor across all three, then voltage phasor will be what? Together, if I add. This is my VC phasor. This is our VR phasor. And this is our VL phasor. Yes or no? And the sum of all three voltages means if I say VC phasors plus VR phasor plus VL phasor, this must come out equals to how much? V phasor. This must come out equals to how much? V phasor. Why? Because all three are connected across an alternating source. This voltage plus this voltage plus this voltage equals to voltage across this one. Yes. Now, so if you just add all these three, what you will get? V phasor will be, so here I will say that this is how much? This is VL minus VC phasor. and this is our VR phasor. And the resultant of these two will be what? V phasor. And what will be V phasor? Root under VL minus VC of whole square plus VR of square. Now what I have written here, very soon you will understand when I will put data there and then I will explain the things. So let me substitute, let me try to answer this problem with the help of some data. Okay. So here I'm just considering, I will I will turn the camera on this side. Hold on. Nobody will write anything. First you will try to understand. Okay. Otherwise you will understand nothing and then you will shout at me. सर क्या पढ़ा है, कुछ समझ में नहीं है. XC is 3 ohm. This is 4 ohm. No, this is 6 ohm and R is 4 ohm. Yeah. This is the question. Here, this is 100 volt. This is RMS value or peak value? RMS. All the readings or ratings are given in RMS value. Is that clear? But here I am taking this as a sinusoidal function, 100 sine of omega t. Okay. Omega value is given in such a way that we know the value of XC, XL and everything. Okay. This is. Now let us calculate the impedance of the circuit Z. Z will be how much? Draw the triangle. Draw the triangle. How will you draw the triangle? Sir, this is our XL. How much it is? 6 ohm. How much here? 3 ohm. And how much here? 4 ohm. Yes or no? What you will get here? This is 6 minus 3 and this is 4. What you will get here? 3 and this is 4. Resultant will be how much? 5. Is that clear? What is the value of Z we got? 5. What is this angle? 5. 5 will be how much? 37 degree. Yes or no? 5 will be how much? 37. Tan theta. Tan theta is 3 by 4. So theta will be 37. So Z phasor is how much? 5 angle 37. Yes. Now let us calculate the current. I phasor will be V phasor by Z phasor. V phasor is how much? V phasor is how much? 100 angle 0. Z phasor is how much? 5 angle minus plus 37. Yes or no? How much we get here? 20 angle minus 37. What is the current equation? I can write I equals to 20 sine. Current leads or current lags here? Lags by how much angle? 37. Is that clear? Now, if I ask you, I phasor we have calculated. Now, let's say there is a voltmeter which reads the value V1 here. This voltmeter reads the value V2 and this voltmeter reads the value V3. Okay, let us calculate what is the reading of V1. Maximum peak reading I am talking about. Which reading? Peak reading of V1. So V1 will be how much? I times R, no, I times XC. Yes or no? I is how much? So 20 and XC is how much? 3. How much we got? 60 volt. And we have already seen there that there the voltage is lagging the current. Yes or no? This is 60 volt and this is 5 ampere. Is that clear? In terms of phasor, I can denote it like this way. Tell me. Is that clear? You just check it here also, na? I is how much? 20 minus 37. And XC is 3 minus pi by 2. Current is lagging, na? So it will be like this way. This is I and this is V across C. Is that clear? If you have a doubt, you can take the reference of that figure. अरे गधा हो. B1 phasor, I phasor cross XC phasor. Okay. I phasor is 20 angle minus 37, XC phasor 5 angle minus pi by 2. 20 current. This is 3. How much we got? 60 angle minus pi by 2 minus 37. Yes or no? So this is our I phasor here and this is our V phasor. Is that clear? V1 phasor. Understood everybody? Understood or not? Okay. Now let's talk B2. B2 reading will be how much? B2 can I write 20 into 4 angle minus 37 directly? No sir, if I write it like this way you will get confused and you will again stare at me. क्या कर दिया? 20 angle how much? Minus 37. R angle that is 4. Angle 0 how much we got? 80 angle minus 37. Yes. So this is I across R and this is V across R. Yes. Is that clear? Now B3 will be how much? I phasor cross XL phasor. I phasor is 20 angle minus 37. XL phasor, tell me. 6 angle 90. How much we got here? 120. 53 degree. Yes or no? So this is I and this is V across L. Yes. Now you just check what is the maximum voltage across capacitor? 60 volt. What is the voltage across resistor? 80 volt. And what is the voltage across inductor? 120. You add all three, how much you are getting? Just check. 60, 120, how much? 180. 180 and 80, how much? 360. 360 can, how it comes greater than 100? Something is wrong. Something is definitely wrong here. Yes or no? That means we cannot add them like this way. And why I cannot add them like this way? Anybody, can you tell me? Because sir, their directions are different. So how we will add them to get 100? Proper vector sum. This is how much? BL. How much? 120. Yes. This is how much? 60 BC. Yes or no? And this is how much? Resistance R. VR how much? 80. Yes or no? Resultant of these two will become here and come in 60 here. Yes. And this will be how much? 80. Resultant of these two, you check what you are getting. 100. Yes. Did you get my point? Yes or no? You cannot add the voltage directly. You have to add using proper phasor concepts. Is that clear everybody? You have to add it using proper concept of phasors, using proper concept. Is that clear? Now suppose if I ask you what is the reading of a voltmeter, this is again important. What is the reading of voltmeter connected here? Let's say V4. Can I say V4 is V1 plus V2? 60 plus 80, that is 40, 140? No. Why? Directions are different. So what will be the voltage across them? 60 square plus 80 square. So why you are squaring and adding them? Because you can check the angle. This is minus 37. No, this is minus this angle and this angle. If you see the differences, what you will find? For V4, where I'm going here, let's say V4. V4 will be what? B4 is, sir, this is B1 and this is B2. And the angle between them, how much is there? 90. So V4 will be how much? Under root of V1 square plus V2 square. Is that clear? Yes or no? Understood? Understood? Chalo, note karo. Is it visible what is written? Everybody? Okay, first of all, everybody will write this side. You have 5 minutes to finish it. 2 minutes, sorry. And then I will rotate the camera towards the other person.